Students, I am here to give a brief introduction to experiment number 3, bulk density and void ratio. And the objective of this experiment is to determine the bulk density and void ratio. Here we'll go with some theory. What is bulk density? And so that bulk density is a measure of the weight of the material per unit volume. It is the measure of the weight of the material per unit volume. Bulk density is determined in kg per meter cube. The bulk density of aggregate depends upon their packing, the particle shape and size, the grading and the moisture content. So we have the aggregates are formed due to so many weathering actions from long years back. They are getting, so it depends upon the packing, the particle shape and the size, the grading and the moisture content. This natural moisture content in the particles or in the sample. So increase in bulk density in the case of loose or compacted sample should be above 15% for coarse aggregate and should be below 15% for fine aggregate. So we at the end of the experiment you are going to calculate the increase in bulk density. I'll show it to you so that you can be able to understand. Here you have increase in bulk density. So the increase in bulk density percentage should be increase in percentage in the case of loose or compacted sample should be above 15% for coarse aggregate and should be below 15% for fine aggregate. So as per the video you are going to see later on, we are going to use this fine aggregate sample. Aggregates in general and sand in particular contain voids. So sand is a material which generally consists of voids. It is a space between the individual particles and in a unit volume of aggregate mass. So already we discussed that voids means the gap between the material and the gap between the particles. Here which is not occupied by the solid mineral matters. It is only occupied by air or water. So these are, we call it as voids which are not occupied by the solid mineral matters. The amount of void space depends on the moisture content and size and shape of grains of sand. So the amount of void space depends on the moisture content and the size and shape of grains, because all are uniform shape, so it will be get compacted and they are very nearer. If we are having irregular shapes with irregular sizes, so we'll have more voids. The value of void ratio depends on the consistency and packing of the soil. It is directly affected by compaction. So if you compact the sample, the voids will reduce. Void content ranges from 30 to 45 degrees for coarse aggregate and about 40 to 50 for fine aggregate. This is the theory for this experiment. So the increase in bulk density should not be more than 15% for fine aggregate. You remember this. So as everything I have explained in this video which you are going to see. Let me explain this observation and calculations before you watch that video. You are going to write this W1 weight of empty mold, you can call it as not cylinder, weight of empty mold. W2 weight of water plus mold. W3 weight of sand with mold. W4 weight of compacted sand with the mold. I'll change this. So bulk density of sand. So volume. So you can calculate the volume of the mold using W2 minus W1 by rho W, density of water. Bulk density in sand, W3 minus W1 over volume of the mold. I am explaining all these calculations first because you will be able to understand when I am doing the experiment procedure in the video. So from that I calculated the percentage voids in sand, specific gravity of sand multiplied by density of water minus bulk density of sand over specific gravity of sand multiplied by density of water into 100. See, this is the tabular form which we are going to do. We'll take the sample state. We are doing for two types of soils: loose soil, loose sand, and compacted sand. You just write down W1 in grams, W2 in grams, weight of water in grams. Weight of water, you will get W2 minus W1. Weight of water, you will get it as W2 minus W1, which is mentioned in the procedure. Volume of container, weight of water over density of water. Now weight of aggregate. Aggregate means it's fine aggregate. Weight of fine aggregate and the mold, write in grams. Just only weight of water, weight of aggregates. So weight of aggregates and the mold minus first weight of this empty mold. You will get the weight of aggregates. So calculate bulk density. Then calculate percentage voids. For everything you have formula how to calculate bulk density of sand, how to calculate voids in sand. So in this example we are going to take specific gravity as 2.65. It's a standard value. So finally you will find out the increase in bulk density. Bulk density for compacted aggregate minus bulk density for loose aggregate over bulk density for loose aggregate multiplied by 100. So these are the results and these are the discussions. So now we'll go with video. Now I am going to explain experiment number 3, bulk density and void ratio of sand. So the aim of the experiment is to determine the bulk density and void ratio of sand. What are the apparatus we require is, we require this sand, water, tray. This is called as mold. This is a tamping rod, weighing machine, and all this we require for the experiment. So like coming to the procedure, first step is we have to take the weight of this mold. So we have to take this weight of this mold and we'll note it as W1. See, I'll note down here the weight. W1 is the weight of the mold. The weight of the mold is 4884 grams. This is the first step. And the second step is to fill the mold with water, full of water. Now take the weight of mold plus water, 7851 grams. W2 is 7851 grams. So which means that the weight of mold plus water is 7851 grams. W1 empty weight of the mold 4884 grams. W2 weight of mold plus water 7851 grams. So to calculate the volume of mold, first we have to divide this, we have to take only the weight of water. So calculating the weight of water is W2 minus W1. It is 7851 minus 4884, that is 2967 grams. This is the weight of water. So once you get the weight of water, we know the standard density of water, rho W is 1000 kg per meter cube. So dividing this weight of water divided by the density of water, we can calculate the volume of mold. Volume of mold is equal to, what is the weight of water? 2967 grams divided over density of water. So if you calculate this, to convert this grams into kg, because this density of water is in kg per meter cube. So converting 2967 into 10 power minus 3 kg over 1000 kg per meter cube. So kg. So finally we will get the volume. I will write it here. Volume of mold is equal to 2.967 into 10 power minus 3 meter cube. This is the volume of the mold. After finding out this volume of the mold, so we have to remove all the water. Remove the water from the mold. So we have to dry the mold first. So before adding sand to this, so be sure that the mold has been dried properly. So after making it dry, the mold dry, take the soil sample into the mold. Fill the mold with the soil sample. It is to find out the density of sand. So make it level using this stamping rod. So now take the weight of this mold filled with sand, W3, weight of mold plus sand, that is equal to, this weight is 9451 grams. 9451 grams. So now to get the individual weight of sand, W3 minus W1. So 9451 minus 4884. 9451 minus 4884. So the weight of sand is, the individual weight of sand is 4567 grams. So already we determined the volume of mold. Volume of mold is 2.967 into 10 power minus 3 meter cube. So to determine this bulk density of sand, same again, weight of sand over volume of mound. So if you calculate this, again same, convert this into kg, 4.567 kg divided by 2.967 into 10 power minus 3 meter cube. This 4.567 divided by 2.967. So the weight of sand over volume of mold gives you the bulk density of sand. So if you calculate this, you will get 1.539 into 10 power 3 kg per meter cube. So this is bulk density of sand, 1.539 into 10 power kg meter cube. After finding out the bulk density of sand, we have to determine the percentage voids in sand. The formula for percentage of voids in sand: specific gravity of sand multiplied by density of water minus bulk density of sand over specific gravity of sand into density of water whole multiplied by 100. So as per the standard, take specific gravity of sand as 2.65. So let me calculate this. 2.65 over density of water is 1000 kg per meter cube minus bulk density of sand 1.539 into 10 cube kg per meter cube over specific gravity of sand into density of water. Whole multiplied by 100. Calculating this percentage voids in sand by solving this equation, we get answer of 41.92%. So this is the percentage voids in sand is 41.92%. Repeat the same steps again to determine the percentage voids and bulk density of the compacted sand. I will tell you how to compact the sand now. So first take a sand sample up to the 1/3 level. So take sand sample up to the 1/3 level and using this tamping rod compact 25 times. So once you compact it 25 times with the tamping rod, again fill sand up to 1/3 level. Now again do compaction for 25 times by using this tamping rod. Now fill the sand up to the top level. So do normal compaction. 1, 2, 3. Now fill the sand up to the top level. And level the top of the mold by using the stamping rod. So once it is leveled properly, now take the weight of this compacted sand as W4. It is 9865 grams. W4, weight of compacted sand with mold is 9865. 9865 grams. So now to know the weight of the compacted sand plus mold is 9865 grams. To find out the only weight of this compacted sand, W4 minus W1, then it comes 9865 minus 4884. It is 4981 grams. So you know this W4 minus W1, weight of the compacted sand. Already you know this volume of mold. So after finding out this W4 minus W1, the individual weight of this compacted sand, we have to find the bulk density of compacted sand. So already you know this volume of mold as 2.967 into 10 power minus 3 meter cube. So you can calculate the bulk density like 4981 grams over 2.967 into 10 power minus 3 cubic meter. So convert it 4.981 kg by 2.967 meter cube into 10 cube. So we'll get 4.981 divided by 2.967. So finally the 1.678 into 10 cube kg per meter cube. Density of compacted sand. So once you get this bulk density of compacted sand, you have to find out the percentage voids. As you remember the percentage voids formula, after calculating the bulk density of compacted sand, you have to determine this percentage of voids. It is, as you know, specific. I'll write the direct equation, you know the formula. Specific gravity of sand, compacted sand is 2.65. Density of water 1000 kg per meter cube minus bulk density of sand 1.678 into 10 cube kg per meter cube over specific gravity of sand 2.65 into density of sand kg per meter cube whole multiplied by 100. So if you solve this, you will get 36.67%. This is the percentage voids of a compacted sand is 36.67%. Finally, you have to calculate increase in bulk density. So increase in bulk density is equal to bulk density for compacted aggregate. So increase in bulk density. So what is the bulk density for compacted aggregate is 1.678 into 10 cube. It is the minus bulk density for loose aggregate 1.539 into 10 cube over bulk density for loose aggregate 1.539 into 10 cube. So if you calculate 0, 3, multiplied by 100. So once you calculate 0.0903 into 100, so the percentage increase in bulk density is 9.03%. So this is the final result, that the increase in bulk density is 9.03%.